Hi, everyone. Welcome to our roundtable discussion on recognizing patterns and time-saving tips for standardized tests, while also demonstrating how to implement the mathematical practice standards. My name is Audra Christ, and I am joined by Maria Sorais and Brian Simeone. We are the instructors for all of the online courses in the NJCTL Mathematics program. Now I'll turn it over to Brian, who has an interesting story to share.
Thank you, Audra. I want to pose this question and ask you, how do you think a student would approach this? If I have 13 raised to the x power minus 12 raised to the x power is equal to 25, what is the value of x?
In all honesty, most students would relate it to the most recent unit they just finished. If that was logs, they may start using log rules to solve for x. However, if they're incorrect or it's a long-winded process, they're going to run out of time and they're going to waste time in a standardized test.
Some may attempt to use guess and check or trial and error. If they did, it would be pure luck whether they would quickly find the answer, which ends up being 2, or be left guessing completely incorrect values, which would end up being more time consuming to work out.
There are multiple ways to solve the problem, but they can be time consuming, and that's a problem on time test. The key with time test is that when a problem seems long, there's always a catch. In this problem, if we can manipulate the 25 slightly, we're able to recognize that this is a Pythagorean triple. The solution to this problem can actually be found in a matter of seconds.
So we have two major pitfalls that students can fall into with this problem, is what it sounds like. One is with our concrete learners recognizing that the Pythagorean triple in a different sequence is still a Pythagorean triple. Some may only recognize it in sequential format, meaning 3, 4, 5, 5, 12, 13, 8, 15, 17. The second is with our higher end learners who will most likely use whatever method they learned most, as said before. And in other words, if they learn Pythagorean triples last, they may recognize the pattern, but if they learn logarithms last, they will try to take the log of both sides and then not know what base to use. So what are some strategies we can suggest to help prevent either pitfall? In the first pitfall, the order is reversed and they have to recognize Pythagorean triple in a different order. So when teachers are covering this topic, I think it's important to emphasize and expose students to variations of Pythagorean triples.
Teachers can foster creativity to recognize patterns by incorporating cooperative learning, whether it's in the form of a think, pair, share, or some form of structured educational grouping. Allow students to create their own problems, solve open-ended problems, or ask students if they can think of a variation to a given problem. Studies have shown that these are some of the most successful ways to foster creativity and remove the tendency for students to fixate on one particular method or version of a mathematical fact.
Well-planned activities like this one can accomplish this and actually lighten the teacher's burden while creating a fun and safe environment. Post-it note activities have become popular, and you can easily Google search them for endless ideas. There are many creative people listening to this, and I'm sure they can think of other activities similar to this one. The goal is to get students talking about math, analyzing math, and creating math.
Exactly, Brian. Recognizing patterns in math does not come easily or intuitively. Students have to practice this skill and develop it by being exposed to problems such as this one beyond the context of the unit where it is taught. That brings us to that second pitfall. How can we help students recognize patterns that haven't just been taught?
A teacher will need to be mindful of reviewing previous topics. Consistently incorporating previous topics into daily lessons or practices can help keep the material fresh and break the last taught, first used cycle. This problem is a great example of just that. Pythagorean triples hidden within the context of an exponential function, which normally would use logarithms to solve.
Let's also not forget that mistakes also help the teacher diagnose and correct misconceptions. Getting students to think creatively, intuitively, or even outside the box may sound like a daunting task, but it actually is already embedded within our mathematical practice standards. and can easily be done with resources such as Post-it notes.
That is very true, Audra. The question itself requires one to look for, make use of structure, as well as make sense of problems to persevere in solving them through different methods. During the cooperative learning activity, as they create and solve similar problems, the students are reasoning abstractly and quantitatively, and then they are also recognizing patterns when looking for and expressing regularity in repeated reasoning.
These are all excellent contributions. That's all the time we have for today. Thank you both for joining me and sharing your expertise. Join us again at our next roundtable discussion.